Right, so let's see here. So if you're looking at our current Canvas page here, so if you scroll down here, kind of open the modules. So we have 4 weeks left in this class. 4. Okay, so if you look here, the week of 420 to 424, we have, so the goal here is to cover the interest class notes and the annuities class notes. And we'll talk more about what that is as we work our way through. And then there's homework assigned, homework 12, and notice kind of laid out the rest of the homework assignments and our last project and their due dates. Okay, so you should everything is right there. So now we know coming down the home stretch, right? We have 4 weeks. We can focus on this to kind of get us through this course here. Okay, so we have the project 4, and then the final exam is our 2 kind of last big kind of assignments here, and then a few homeworks, and maybe 1 or 2 in-class type of assignments like we had last week. All right, do you guys have any questions on that? That is up to you, Renee. I think they've extended the pass, no pass, but that is something that you would have to look into, okay? Or you have to decide what you would like for this course. So I will tell you, so just on my end, what I know is that the CSU system and the UC system, although someone was telling me not all the schools are on board with this yet, but depending on what school you want to transfer to, if that's the goal, a university you want to transfer to, some of them have what's the word I'm looking for? Have waived the number of pass no pass classes. So before there was a limit as to how many you could do for a as in the community college, but since due to this pandemic, they waived the number, so you can do essentially all of them if you would like, and it should not reflect negatively on your record. Okay, so so that would be up to you, I guess, decision you would like to make. Okay, then in that case, then I mean, then really the grade will not matter, as long as you just pass the class. All right, but again, everyone's situation is different, so you can kind of look into that. And I believe you can still apply for the pass no pass. They've extended that again for due to this pandemic, as well as the I'll mention it again, the extraordinary withdrawal for any classes you have up to the last day of the semester. If you decide that you don't want to continue with this, it was just too much balancing everything, then you can apply for the withdrawal, and it will not show up on your official transcript. Okay. All right. Okay then. So let's see here. Let me get us to OneNote. All right. Good morning. Okay. I have not even looked at the midterm. Sorry. I was it's I can only, well, it's kind of different for myself as well, grading all of these, like I was mentioning earlier. So I'm not exactly sure. It's going to take me a minute to kind of get through all of them. All right. Usually I like to grade 1 page at a time, just to see everybody, just to keep consistency. But that's kind of really essentially impossible to do that. Not impossible, I shouldn't say that. Really time consuming. So I think I'm just going to go through 1 whole exam at a time and then kind of grade it that manner. Okay, so just kind of my process of what I'm telling you. And I had, well, anyways, I'll get them as soon as possible. All right. Okay. Okay, and again, there's an extraordinary withdrawal. So if you're worried about whether you want to continue with this class based on that exam, in that sense, there is no rush on that. All right. Thank you, Renee. Yes, thank you. Okay. All right. So today we're going to maybe talk about, well, not maybe. So we're going to talk about, this is our finance section in our math textbook here. And I think here, hopefully this will be something that you can kind of apply to your own kind of circumstances and life. Very helpful if you ever thought about, or if you have a credit card, right? If you're thought about buying a car or leasing a car, excuse me, right? Or buying a home. Okay, so some things like that, then we can kind of start talking about what we're going to look at, kind of formulas to help us calculate things like monthly payments, right? Stuff like maybe you want to think about retirement, right? Which maybe right now sounds like for some of you that is forever, but what we'll find out is kind of the benefits of starting. The earlier you start for saving in general, really the better, due to this kind of compound interest that we will discuss. Okay, now first, one thing that we can kind of start thinking about when we think of buying something like a large purchase that requires us to take out a loan of some sort, is we always ask how much does something cost, right? Which is not really the right answer, or excuse me, the right question to ask yourself. Really, the question you want to ask yourself is how much can I afford, right? And then that question should guide now what you can buy. All right, a much more sensible approach. All right, and we can kind of think of some of these formulas that we're going to use here to just to calculate cost of certain things, right? If a loan is taken out. All right, now the first kind of step into doing this is just calculating a simple interest, right? So here, if we're all looking at the same thing here, right? And again, these notes, like all the other notes, can be found on Canvas. Just go to the modules and it'll link you to the PDF copy of this. All right, so the first type of interest is we're gonna look at as something called simple interest, right? So as we see here, there are two formulas we're looking at here, this one and this formula here. Okay, now the first formula, I equals to a couple of things here. This P with a subset of 0. The way we pronounce that is P naught. All right, or P initial. We can sometimes refer to it as P initial. All right, so that subscript of 0, that's how we kind of interpret it, right? Now, the first formula that we see here, so formula 1, what that does is it calculates interest. All right, strictly interest, right? So if that's all you're interested in, how much interest is being accrued, then you would use that formula. And again, this is for simple interest. We'll talk about something called compound interest a little later, right? But for simple interest, we use that formula, right? Where we look at here, all of these are I is the interest, A is the end amount, and we'll get to that in a second, and P naught is the principal, whatever we get started with. R is the interest rate in decimal form, all right? So keep that in mind. Here we want it in decimal form, more importantly, not a percentage. All right, and T is time. All right, usually in years. Okay, but it does not not necessary. All right. Okay, now for simple interest, like if you borrow money from like let's say not necessarily a bank, right? And they just give you a kind of a set formula. Let's take a look at this example that we see here, right? It says you asked to borrow $1,500 from some person, some entity, and agree to pay it back in 2 weeks with a 4.5% interest. All right, so how much interest would you pay? Okay, so in this case here, it's not structured like when a bank, they tell you it's an annual interest percentage rate. So in this case, it says 2 weeks for 4.5% interest. All right, so I want to use, if I want to calculate the interest, I want to use this formula. All right, now this type of problem is a special kind of one-time loan where you borrow $1,500 and then you're going to pay all of it back with the interest. Okay, so if that's the case, I'm going to set T equal to 1 because there's no kind of payment plan that you're going to set up. Okay, it's simply a quick, maybe you borrow it from a friend, right, or from some acquaintance. It's all right, I'll pay you 4.5% interest. Okay, so in this case, our initial amount is the amount we're borrowing, right? So P naught is going to be $1,500, right? And the interest rate, the rate is 4.5%, but again, right, in decimal form. So when going from percent to decimal, we move the decimal place over 2. So we get this to be our excuse me, to be our rate. All right, and now let's plug this all into our formula. And we have 1,500. And then T is 1. Okay, and then I'll just plug all that into my formula. 1,500 times 0.045 times 1. So we get $67.50. All right. Just the way that the problem is structured, right? Here it doesn't say, it's not said like a 4.5% annual interest rate. It doesn't say anything like that, right? It's very informal. It just says, you let me borrow 1,500, I will pay you back in 2 weeks with 4.5% interest added on top of it. Okay, so it's just kind of a less structured type of borrowing, right? We're going to look at more structured where it's maybe through a bank where you have a percentage, annual percentage rate, right? And then that's taken from there, and then maybe it's compounded monthly, weekly, quarterly, stuff like that. Well, not given unless it's worded a bit differently, right? So again, much like our statistics problems and our probability problems, we have to be very careful with how it's worded, all right? So in this case, if we see here, it just said the way that it's phrased, right? It's a very basic where it says you borrow 1,500 and you says agree to pay it back in 2 weeks with 4.5% interest. So there's really just one transaction. You borrow the money, then you come back and you pay all of it with a 4.5% interest. All right, now we'll take a look at savings accounts. Now those work a little bit different, right? Where we have maybe a certain interest that it's being, because it doesn't say 4.5% interest per week. If it said that, then we would let T be 2. Okay, so here it just says 4.5% interest, right? There's no caveat as to how often that is getting charged, right? If it said daily, then we would say, all right, 2 weeks would be 14, then T would be 14 days. Okay? All right. Okay then, so now that would be the interest. Oh, now how much money do I actually pay back? All right. So after 2 weeks, you should show up with $67.50 and be like, here you go. Thank you for the loan. What do you guys think? Correct. That's the 1,500 plus the $67, right? And 50 cents, right? So how much money is paid back? It'd be the original loan amount plus the interest. All right, so that is 1,567.50. All right. Any other questions on this problem here? Okay, so now let's take a look at something that is, okay. All right, so now let's take a look here at this next example here. It says Maria takes out a loan for $6,000 to start a business after high school. The bank charges her 8% interest for the loan. All right, after 5 years, how much interest will be added to the loan? Now here, it's not stated explicitly. Yeah, it doesn't say it's annual or not, correct? right? But if it's not stated explicitly, we're going to, but if it says it's for a bank, if we're dealing with a bank, right, we're gonna assume that this is 8% interest per year. Okay. Yeah, we'll assume, well, no, we won't assume, we'll assume per year you're paying 8% interest, right? So if we're dealing with some kind of institution, and I'll make sure to write it out explicitly, but we can assume that if it says it's from a bank, that when you deal with a bank, we can clearly see that we'll assume that their interest rates are always per year. Okay. So it says after 5 years, how much interest will be added to the loan? Okay, so we can say, all right, so how much interest, if we're looking strictly for interest, right, we can say, all right, I'm gonna use this right here, the interest formula. All right. Okay, now you could use the second formula, but just realize that that's always gonna be the total amount. All right, and if you wanted to find the actual interest, you had to do some subtraction at the end. All right, so why don't we actually use formula 2 so we can kind of see what I'm talking about here, right? So formula 2. It depends on what they're asking with, Jorge. Like, again, right? A lot of these, we have to be there's no like, you have to just look at what the question is asking and you have to determine, am I looking for the interest or am I looking for the total amount? And that's the decision that's gonna guide me. It's gonna be the clues that we find in the problem, right? This one says how much interest, so I'm looking for interest, right? So I think interest formula, right? If they're asking me for the amount of the loan, right, then I can calculate that using the second formula. Okay, now notice here that this is an example of what's called compound interest, right? Because we're looking at 5 years, but this interest is calculated per year. All right, so if you say, all right, let's start first with year 1. All right, and let's figure out at the end of year 1, how much am I gonna owe, right? So what is the amount at the end of year 1? Okay, so looking at formula 2, we said the amount is here. Actually here, let me, we can just go ahead and calculate. Let me reverse back here. I made a mistake here. All right. So A times 2. Okay. So I'm going to use this formula to just calculate the amount at the end of 5 years. And I'm missing the P naught, yes. So times P naught. Okay, so how much interest at the end of 5 years? Okay, so they tell me the time, right? So when we're given this, let's identify what values we know, right? And then which ones we don't know, right? So if I look at this formula, I don't know this, right? That's what I'm going to calculate, right? I do know the rate, right? That's always easiest to pick out, right? It has a percentage most of the time, unless it's given to us as a decimal. And I also know the P naught, right? The original amount that was taken out. Okay, so here, let's say, okay, so in this case, we have Yes, it's in the inside of the parentheses. It's one, excuse me, yeah, it's a one. Okay, so if we look at here to plug in our formula, rate is 0.08, time is 5, and then the P naught is $6,000. Okay. So we get 1 plus 0.08 times 5 times 6,000. We get $8,400. Okay, now again, right, keep in mind that the formula that we use is not the interest, it's the total amount of the loan. Okay, now how do we actually calculate the interest from this? Well, I know how much originally was taken out, right? What was the loan for? So to calculate the interest, we do need to do one more operation. We would take this 8,400, right? So that's the total amount, including the original amount plus the interest, and subtract away the loan amount. Right, and that would be here, $2,400 in interest. Okay. All right, now notice this is a very simplified problem where if really we're thinking of, if we're taking out a loan, we would be doing monthly payments, right? And then that would kind of, each point you're kind of working towards paying each month, or however you structure the payments, you're working towards paying down the balance, right? As long as we're paying some interest along the way. No, that would be the, not the monthly, but over 5 years, how much interest was paid. All right, hence that's why Q was equal to 5, right? That would be over the total of 5 years. All right, now again, like I said, this is a very simplified problem here, where we're assuming that no payment was made throughout those 6 years, or 5 years, excuse me. Now later we'll introduce, we'll look at a more realistic problem where we think, all right, this is how much the interest rate is, how much our monthly payments are, and then kind of work through it that way, right? But for now, we'll look at a kind of a very basic problem, and then we'll add some complexity as we move along. It's multiplication. So, I mean, if you think of what's the difference between 3 times 4 and 4 times 3, right? It's the same thing, right? So here, I just rearranged it mainly because I forgot the P naught when I first started writing. So I just wrote it at the end. Yes, you still could. Okay. Any other questions here? Yes, 2,400 in interest. Correct. Correct. That corresponds, and we look at what A is the end amount, principal plus interest. All right. Okay. So let's take a look at kind of what's called an APR, an annual percentage rate. So interest rates are usually given as an annual percentage rate, the total interest that will be paid in the year, right? So again, we're looking at T in years. If the interest is paid in smaller time increments, the APR will be divided up, right? So for instance, sometimes they offer, right? So maybe they'll say terms like 4% annual interest, compounded monthly. All right. So when that's the case, you don't get 4% every month. You get the 4% for the year, and that gets divided up into the 12 months. All right. So to find per month, you would take 4% and divide it by 12. All right. So in this case, let's take a look at our formula here, and let's kind of take a look at what each one of these variables represents. All right. So it says, so P sub n equals to P naught times this quantity, 1 plus R over K, N over K, N times K, excuse me. All right. So it looks very similar to our amount formula in the previous one, but here we kind of had to add some things because we're, maybe it's not, the interest is not simple where it's compounded at the end of the year. It's compounded within the year as well, depending on what the value of K, right? So P sub n is the balance in the account after n years, right? Think of it like if this was a savings account, right? And P naught is the starting balance of the account, also called the initial deposit. And again, for these first ones, we're going to look at a very simplified problem where we make one large deposit, right? And then we just kind of leave it in the account and don't touch it and let the interest accrue, all right? And again, right, this is not realistically kind of how most people save, right? Usually in some cases you put down money each month and then the interest accrues, right? But you're adding into that account, right? And again, later in this section, we'll take a look at how to perform those types of calculations. Okay, so P sub n is the balance in the account after n years. P0 is the starting balance, or P naught. R is the annual interest rate in decimal form. And K is the number of compounding periods in 1 year, right? So for this first kind of formulation, 4% annual interest compounded monthly, K would be 12, all right? Sometimes they say, all right, maybe 3.5 interest, annual interest, compounded quarterly. In that case, K would be 4, right? 4 quarters in a year, right? Or every 3 months, the interest is compounded, right? And then maybe you'd say, all right, what if we have 3.5% interest compounded monthly? Excuse me, I did monthly. Let's say daily. All right, and we'll say K is 365 in that day, right? Now, it seems like, oh, you would kind of get more money if you compound the interest more often, right? And while that is true, it is not as much as we think, right? And the reason for that is because, again, right, that annual interest rate, if it's compounded monthly or let's say quarterly, right, you don't get 3.5% every quarter. It's still over the year. You just kind of break it down. Instead of doing it at the end of the year, you do it 4 times within the year. But you just take that 3.5 and then you divide it by 4. Okay, so for example, let's look at a problem here. Let's take a look at this, right? So for this example, let's say you deposit $1,000 into an account, earning 3 3.5% interest rate. Right, per year. And I want to calculate the amount in the account. The total amount in the account at the end of 1 year if the interest is compounded. We'll say A, monthly, B, quarterly, and C, daily. Okay. So we have 3 different calculations here, and we'll see how the, so really everything else is gonna, the initial amount, the interest rate, and the time period for 1 year is gonna remain the same, right? So for our calculations here, overall, P naught is 1,000, right? The rate is 0.035, remember always as a decimal, right? And then T is 1, or let's see, hold on, I called it N in this case. So here, K is the number, N is years. So N is equal to 1. Okay, all right. So that is the same for part A, B, and C, right? Those parts are going to remain the same. All right. So what is going to change is K, right? The number, how often I compounded throughout the year. All right. So for part A, monthly, K is going to be 12. Okay. So we look at our formula and we say, all right, I'm working with, let me write it down here so we have easy access to it. So P sub N plus R over K and K. All right. Okay. Oh, again, I forgot that P0. All right, so here is what we're gonna find out here when we were doing, it's gonna be similar to our geometry kind of portion, is when we have some kind of problem, we wanna ask ourselves, right, WTF, right? What's the formula? All right, there's gonna be a lot of these, it's just our first one. So we have to be able to decipher which one we need to use, right? For now, it's just one, so there's not much of a choice here when we're talking about compound interest, right? So K would be 12 for monthly, right? So let's see here. So let's plug in after 1 year. So if N is 1, we're looking for we'll look at P1. The P naught is 1,000. The rate is 0.035 over K, which is 12, and that raised to 1 times 12. Okay, so we wrote it down. We're looking at this calculation here, right? The next thing is I need to calculate this. So let's look at, let me bring up my calculator here. Let's look at, all right. Okay, so let me clear here. Okay, and okay, and now let me plug in. So 1,000. Oops. 1,000. Open up parentheses, and then we have 1 plus 0.035 divided by 12. Close the parentheses, and I'm going to raise it to the 12th power. So now notice we have basic exponent functions for square, but there isn't one for anything bigger than that here. So what we use is this little caret symbol right here above the division one. So notice that'll get you in exponents. Okay, and then now we plug in the exponent there. Depending on what version of a graphing calculator, sometimes it will show the symbol caret. If you're going to do operations in the exponent, make sure you open up a set of parentheses. But after that, we add it all up there, hit enter, and now we have that 1,035. So let's see here. So $1,035. We're dealing with money, so we'll round to 2 decimal places. All right. So let me go back to our notes here. So here, after 1 year in the account, we would have had okay. And again, that's if I have interest compounded, excuse me, every month. All right. So now let's look at quarterly. Now here, the interest is compounded. If we're dealing with money, 2 places is usually, again, right? Money, it would be always to 2 decimal places, right? To go to the cents place. Okay, so now for part B, all right, so in this case, we have a quarterly. So again, remember, P naught, R, and N are gonna remain the same. What I'm gonna change here is the K. So K is equal to 4. All right, so quarterly, right? So every 3 months, the interest rate is calculated. Now, kind of intuitively, I would expect that if K is 4, I should earn less interest than if I did it over the 12 over the 12 months of the year. And let's see if that is confirmed here, right? So P1, right, is going to look at almost the same. Okay, so it'll look like this. And now let me bring my calculator up here, right? Now, a nice thing of these calculators is I can bring back my previous entry by just hitting second and then enter, and that brings back everything you wrote in the previous line. And I'm just going to go ahead and change that to 4. All right. Okay, so now we have something like this. All right, for quarterly, I hit enter. And then we have 1035 with 46 cents. Okay, so as it turns out, we do make more money by going monthly, right? But as you notice here, that increase was a few cents, right? Okay, so it's not as much as I hoped, right? Now, what about if I went daily, right? Every single day, I'm compounding interest, right? So in this case, we'll say K is equal to 365, right? So at P1, we would say, okay, so 1,000. This looks like I should be making way more money here. Over 365, and then 1 times 365, right? That's where the changes would be made, right, in the K. All right, so now let's bring back our calculator again here. So here, oops, let me bring back my previous entry. And now let me change everything here to 365. All right. All right, so it should look something like this. Oops, what did I do? All right. Okay. All right, and then I'll hit enter, and we see we get 1035.60, or 62 if we're rounding to correct 2 decimal places. Okay, all right, so now you notice here in each case, right, it does follow what I think would happen is that the more often I compound the interest, right, the more money I should make, right? What doesn't follow is that we went from 12 to 360, or from 4, really, our lowest number, all the way to 365, and our gain from that was really almost not even 20 cents. All right. So the reason that is kind of, if you look at, while the number K is getting larger, it's happening in the exponent, but it's also happening inside the 1 plus R over K. So both of those are kind of counteracting each other, so it doesn't kind of grow as much as we would actually hope for, right? So it does look like there is a small advantage, but not as much as we would think if you think of interest that we compound every day as opposed to 4 times over the year. All right. Now, we don't cover this in this class, but if you think of interest that's compounded every hour, every second, and what is called continuous compound, it actually doesn't increase much more than that, right? In fact, if you ever know what that, if you heard of that number, the natural number, or the natural number E, or logarithms, these kind of converge to that number, but that's a topic for a different course here. For now, we're just interested in calculating percentages, or excuse me, interest over a certain time period. Okay, any questions on this example here, or just kind of applying it to the formula here? Okay, so now let's take a look here. So it says Brenda invests $4,848 in a savings account with a fixed annual interest rate of 5% compounded 2 times per year. What will the account balance be after 6 years, right? Again, right, we get this formula, well, excuse me, we get this problem, right? For now, there's only really one formula that we have if it's compounded 2 times a year, right? So we're going to be using the compound interest formula. So let me again write it here so we have it as a reference. Okay, so we've identified the formula. All right, and now let's figure out what we are looking for, right? So we're looking for the account balance after 6 years. So again, what will? So that's what we're looking for. Excuse me. All right, so we're looking for P6. All right, now notice here, right? If I'm looking for P6, that means that I should be able to identify everything else in here, right? N is 6, K is 2, right? Compounded 2 times per year. All right. And then again, the rate is always the easiest one. It has a percentage, but don't forget to change it to a decimal. All right, R is 0.05. Okay, R and K, and then our initial investment is here, right? From our initial amount here. Okay. All right. So we have our kind of initial, again, I would encourage you guys as working through these problems, especially to begin with, is list out all the variables, right? Do what I did here, right? Have the formula right next to you, right? List out all these variables. And then now once it's there, you set it up and actually write it out, right? Don't just jump to the calculator, right? Let's say P6 is gonna look like 4,848, 1 plus R, which we said was 0.05, over K, which is 2, and then N was 6 times 2. All right. Okay, so now we have here, we put that there. So now the next challenge here is performing the calculation via the calculator. All right, any questions so far on the setup here? Okay, so here again, right? I just want to reiterate here. This is a very simplified problem in the sense that we're assuming we assume no additional deposits are made, deposits or withdrawals. And or withdrawals. Okay. Later we'll introduce more complexity where we do the case where maybe each year, or excuse me, each month I add something to my account, and how does that build over time? Okay, but for now we'll look at a very simplified problem. Okay, so now we have this here, and let's put this in our calculator. Okay, so here we'll start 4848. Open up a set of parentheses, and in that parentheses I'll put 1 plus 0.05 divided by 2. Close my parentheses, get in the exponent using that caret, and up there I'll have 6 times 2, which is 12. All right, and then hit enter, and we see that after 6 years, there is $6,520 with 2 cents. $6,520. Okay. All right, any questions on this example here? Okay, so here, let me let's move on to the let's take a look at this example, right? Now this one is going to it's asking for something a bit different, right? So let me read this example here. It says Juan invests a sum of money in a savings account with a fixed annual interest rate of 4.31% compounded. I'll use that word again, compounded 12 times per year. After 10 years, the balance reaches $12,855 with 94 cents. What was the amount of the initial investment? Excuse me. All right, now notice here they're asking for something very different. All right, so before we were asked how much we had the initial amount, right? Excuse me, let me scroll up here. Right, we knew what we started with. In other words, we knew P0, and then we wanted to calculate what was there after some time period. But that's not what we have here, right? Here we have the ending amount, right? After 10 years, the balance reaches that number, right? So here we actually have what we end with, right? So that's kind of different than the previous problem. No, we're going to still use the compound formula because it's still compounded. It's still compounded interest, right? We just have to use it differently, right? So here, we still need to use this formula because it's still compound interest. All right. The only difference here is that, so let's look at what else I know. I know the rate, right? That one's always easy to identify. And K is 12, right? Compounded 12 times per year. What I don't know is the initial amount of the investment. Okay. So I still need to use this formula. I just needed to solve for P0. Now, the way I do that is what I can do here is I can divide both sides by this quantity. Right? Same rules of algebra still apply here. We're dealing with an equation. Right? So when I divide by those, again, notice here, this reduces to 1. So a way to solve for the initial is Pn divided by 1 plus R over K to the n times K. All right, so a little algebra gets me to a new formula, right? From the old one, right? We just did some manipulation, right? And now I can solve for P0, right? So I can just plug in. So now let me plug in the values that I know. Is P, in this case, 10. Okay. All right, so here I'm looking for P10, right? So excuse me, I'm given P10 and I need to find my initial amount, right? So starting with the formula, I'm still going to use that same formula because it is dealing with compound interest, right? But in this case, I'm solving for a different variable, right? I know the P10, they're giving me that. I need to find out, I would like to find out the initial amount. All right, so with a little algebraic manipulation here, dividing by this whole quantity here, right, I get back to this formula, which allows me to solve for P0. Okay, so now applying it to my problem here, P10 is 12 with 94 cents. All right, and then now I'll plug in the bottom here, 1. R is 0.0431 over K, which was 12. And then up here, N is 10, right, for 10 years. Up in up in the exponent, we'll have N times K, so 10 times 12. Well, when you mean by all cases, this is the case where we're looking for the initial amount. So I'm solving for the initial amount. If that's our goal to solve for the initial amount, then yes, we would divide by that whole quantity. The 1 plus R over K to the exponent, whatever, to the exponent N times K. So if our goal is to find for the initial amount, then yes, this will always be, so this would always be the formula that we're using, right? If we're solving for the initial amount. Okay, and again, I did it once, so now if I just kind of reference this in my notes, I can just remember, all right, that's the formula that I used to solve for the initial amount. No, I think this is the most straightforward way to approach a problem like this. Okay. All right. So here we have, so now let's, comes down to plugging this into our calculator. Okay, so here we'll have $12,855.94. And I'm going to divide that, open up a set of parentheses, and I'll plug this in. 1 plus 1 divided by 12. And again, raise that to 12 times 10, which is 120. Okay, and then once it's all in there, I'll enter. And it looks like we had $8,361. $0. Okay. All right. Any questions on this example? All right. So again, what we're going to find out, especially the further along we go along in this section, is we have to be careful. Just kind of make sure you read the problem, properly understand what type of situation we're in, right? For compound interest, and moving forward, all of the problems will be some variation of compound interest. But it'll be a difference in, are we investing money? Are we borrowing money? Right? Are we paying off a loan? Right? Are we saving for retirement? But all of those are just variations on this compound interest formula. Okay, and we'll see what effects it has when I allow for maybe a monthly deposit, right? Maybe every month I put away $200, right? Or whatever that amount is. Okay? All right. Any questions on this example? Sure. I mean, this part here. I mean, these notes will be on Canvas. These notes will be on Canvas by the end of today. And, okay, if there are no other questions, we're gonna call it a day here for today. All right, so